Welcome to this lesson. We're going to take a look at chemical formulas and equations. So this topic is going to be delivered into two videos. In the first video, we're going to take a look at chemical formulas. In the second video, we're going to take a look at state symbols, chemical equations, and ionic equations. Let's get started. So we're going to start with chemical formulas, but the basic principle behind chemical formulas is what is called a valency. So what's a chemical formula? So chemical formulas are just the way we represent compounds or compounds with symbols, the symbols of elements that are on the periodic table. We have salt, which is a compound, an ionic compound. Its chemical name is sodium chloride. So how do you write sodium chloride? So you write sodium chloride as Na, capital N, small a, capital C, small l. That is sodium chloride. So we're going to learn how to come up with these symbols. And the secret behind coming up with these symbols is comes from the knowledge on valency. So what is valency? Valence is defined as the number of electrons lost or gained or shared by an atom of the element to attain a stable structure. We talked about valence shells, which are the outermost shells. We talked about valence electrons, which are the electrons in the outermost shells. Valency on its own is just a number of electrons lost or gained or shared by an atom so that it is stable. In short, it is said to be the combining power of an element. So what does this phrase mean, combining power of an element? So when sodium and chlorine are about to combine to form sodium chloride, which is common salt. So sodium has its valence and chlorine has its valency. So when you mix them, these valences are going to play an important role in coming up with the chemical formula of the compound. So we have some elements here with their valences. So here are elements, here are valences. So potassium has a valence of 1. Silver has a valence of 1. Then there is an element which maybe you might not have heard of it, copper 1. So there are different types of copper. There's copper 1, copper 2, just like that. So copper 1 has a valence of 1, calcium has a valence of 2, iron 2 has a valence of 2, zinc has a valence of 2, and hydrogen has a valence of 1. So these are many. Of course, some you have to master, but not all of them. Especially for the elements, you don't have to master the valence of elements. So the secret behind valency is based on the periodic table. The group number of an element will give you an idea of its valency. For metals, those which are in group 1, group 2, group 3, group 4, the group number is the valency. Potassium is in group 1, that's why its valence is 1. Sodium is in group, there's no sodium here, but sodium is in group 1, its valence is also 1. I'll skip this, silver and copper 1. I'll go straight to calcium. Calcium is in group 2, its valency is 2. But there are some elements which are called transition metals, which are found between last time when I introduced the periodic table, there are those group of elements which are between, I think, group 2 and group 3, which makes the structure of the periodic table not as pretty as it should be. So those elements are called transition metals. So those ones, the valences you have to master. And some of those metals are silver, copper 1, iron 2, and zinc. So these are transition metals. So their valences, you have to master them. For silver, it's 1. For copper 1, it's easy. This one will tell you the valency. It's 1. If this was copper 2, then its valence is 2. For iron 2, is 2. For zinc, this one has to be mastered, is 2. So there are three, from here, there are 3 types of elements. Hydrogen, I haven't talked about it. I'm going to give you more info about it. But for metals, these metals here, they can be classified into 3 for now. There are those which are in group 1, group 2, group 3. So those ones, you just get the group number. Those ones in group 1, the group number is the variance. Those ones in group 2, the group number is the variance. Those ones in group 3, the group number is the variance. But these ones like silver, copper, which are in between group 2 and group 3, the transition metals, these ones, yeah, like silver, you have to master. Then for copper one, this is the third kind, copper one, which you just get the valency from this, from the name. Copper one, the valence is 1. Copper 2, the valence is 2, just like that. So these are the 3 classifications for now. So we have the ones that we get direct from the group. There are the others which are between group 2 and group 3, which we cannot get direct because they don't belong to any group for now. That's what we can say. So those ones, you if it's not stated like this, copper 1, copper 2, then you have to master. Silver, you have to master. So those who have access to the notes, you're going to see the list of all the elements, those which you need to master and those which you don't need to master. So that's the secret. So whenever you're given a compound, let's say potassium carbonate, you have to understand or to ask yourself what elements makes up this thing which have been given. So once you separate these elements, you go on the periodic table, you see if they are in group 1, group 2, group 3, or group 4 going up. If they are not, then you have to ask yourself if they are part of the transition metals. In that case, it must be you have mastered them, but they are not main these ones which you have to master. Maybe there are 3 or 4: silver, gold, iron, if I'm not mistaken. But in the notes, all that information is well provided. Then on the non-metals, we have hydrogen, which is 1. Hydrogen belongs both to group 1 and group 7, so it's difficult to give hydrogen a group because it behaves as a metal and sometimes as a non-metal. So hydrogen does a valence of 1. Another one which you can take a look at valences is the number of outermost electrons for metals. Potassium has 1 electron in its outermost shell, that's why its valence is 1. Hydrogen has 1, its valence is 1. Calcium has 2, its valence is 2, just like that. So this is another way of looking at it. So just give yourself time to think about it. Let's take a look at other non-metals and the secret to determining their valences. So by the way, before we can even start, take a look at other non-metals. Hydrogen, if we look at it as a non-metal, so the secret is for non-metals, you get the group number, then you do 8 minus group number. The number that you're going to get is the valence of a non-metal. So hydrogen behaves as if it is in group 1 and also as if it is in group 7. So for that, 8 minus 7 is going to give you 1. So hydrogen has a valence of 1. So these are other non-metals. Chlorine is in group 7. 8 minus 7 is 1. Nitrogen is in group 5. 8 minus 5 is 3. Phosphorus 3. So this one they have stated is phosphorus 3 because of this. So the valence is 3. Other than elements, they are what are called radicals. What is a radical? So a radical is a group of atoms which is present in several compounds but incapable of independent existence. So a radical is just a group of atoms which have this weird behavior of being found in different compounds, but you'll never find them alone. So here are some radicals, and they've got valences because from time to time you would be required to combine or to combine an element with a radical to form a compound, and in that case you need to know the valency of a compound. So the first example of a radical is ammonium. So there's this NH4. Nitrogen and these 4 hydrogen atoms, they have got a tendency of being found together in this form NH4, and they will always have this formula NH4, and they will combine with different elements to form compounds. So we can have things like ammonium chloride, ammonium sulfate, but you never find ammonium on its own. There's no such a thing as ammonia, but ammonium sulfate is there, ammonium chloride is there, but you never find ammonium. So that's what a radical is. It can be found in different compounds, but you cannot find it alone, and it's a group of elements which have this strange behavior. So ammonium chlorate, chloride, hydrogen carbonate, hydrogen sulfate, hydroxide, nitrate, nitrite. So all these, you have to master their symbols and their valence. The valence is 1. Their symbols are these. There are more radicals with different valences. In the notes, they are all there. So that's just a bit of an insight, because mastering this is not a joke. Yeah, you need a lot of you need to put in work, but with time you get used to knowing what the valence of for example, hydrogen carbonate is. uh, with me, as I was trying to develop the experience, I came to figure out some patterns. One of the pattern is anything that has hydrogen, any radical that has hydrogen, its valence is 1. Remember, the valence for hydrogen is 1. So if you look here, anything that has hydrogen in it has a valence of 1. So that's just a hint, which is not a fact, like a verified fact, but it's something that is true for, like, it's a secret that I'm giving you. So you can take that, or if you want you can leave it. Yeah, but that's all about radicals. So these are other radicals. I've got carbonate, oxide, sulfate, sulfide, sulfide. And be careful with these three. Sulfate, SO4, sulfide, sulfite, SO3. The valences are 2. Then we have this one, phosphate, which is PO4, and the valency is 3. So now we begin the main topic, or the main issue why we are learning about valences, so that it all makes sense now. Chemical formulas. So a chemical formula consists of a symbol or symbols showing the number of atoms in one molecule of an element or a compound. That's what a chemical formula is. So to write a chemical formula, you have to do these steps. First, write the symbol for the combining elements or radicals. So the elements that are participating in that chemical that you're about to write the formula for, the elements that are participating in that compound that you want to write the chemical formula for, you have to write them. For example, carbon dioxide, you have to write carbon and oxygen, because carbon dioxide is made of carbon and hydrogen. So you should develop that insight of knowing what the elements are making a given compound. If they say carbon dioxide, you have to know that there's carbon and oxygen. If they say sulfur dioxide, the dioxide should tell that there's oxygen. The oxide is oxygen, chloride is chlorine, sulfide is sulfur, just like that. So the second step is write the valency of each element or radical at its top right hand side, like this. So for example, sodium, the symbol is Na, and write the valency on top. The sodium is in group 1, so its valency is 1. So one thing I want to emphasize here is some of us have bad handwriting, so you might end up writing sodium as capital N and capital A, which is not acceptable. If you write sodium as small letter N and a small letter or capital A, it's unacceptable. Sodium should have capital N and small a. So all elements that are represented or that are written with 2 letters, the first letter should be capital, the second letter should be a small letter. If they are both capitals, then it means it's a radical, or it's a compound or something. It means there are 2 elements involved there. Anyway, that was just a side hint. 3. Exchange the valences of the combining elements and radicals by writing them at the bottom right hand side of the element or radical. If the number is 1, do not write it. So what I'm trying to say is something simple, like this. If you haven't understood this, the English here, you can just take this demonstration. So let's say we have sodium and chloride. They are about to combine to form sodium chloride. So sodium, you put the valency, which is 1, and chlorine, you put the valency, which is 1 for chlorine. Chlorine is in group 7, so it's a non-metal, so it's 8 minus 7, 1. 1 is the valency. So now that we have sodium and chlorine with their valencies on top, what we do next is we combine them but these ones are going to exchange like this. So so just pay some attention here. So this one is going to come here and this one is going to come here like this. So this one is going to come here and this other one is going to come here. That's what they do. So this one has come here, this one has come here. So now when you have this, you are done. But before you can be sure that you are done, you have to check at the numbers. If the numbers are the same or they are not in the lowest terms, those who know mathematics, like if you have 4 and 2 here, you can reduce like 2 into 2 1, 2 into 4 2. Yes, but what you have to take is usually you have same numbers. If the numbers are the same, then you can cancel them out. Like 1 is going to cancel, 1 is going to cancel, and you're going to have sodium chloride. So let me just summarize the important point you have to take here. So you write the symbols, you put the valences, then you combine the symbols, the valences, you bring them here. The valence for sodium will be here, and the valence for chlorine will be here. When you do that, look, if the numbers are the same, you can cancel them so that you write without numbers. If they're not the same, you leave them just like that. So in some formulas, radicals are written in brackets followed by a small subscript digit. If the language here is confusing, what I'm trying to say is this. If you want to combine aluminium and carbonate to form aluminium carbonate, here is what happens. So you have aluminium with a valence of 3. Why? Because aluminium is in group 3. Then you have carbonate with a valence of 2. Carbonate is radical, so its valence is 2 if you have mastered from the tables. So from there, when you combine, it's going to be like this. How? So the 2 has come here, then the 3 has come here. But notice that this 3 is coming here, but there's already a 3 here. So to avoid this confusion, the entire radical, put it in brackets. But if the radical, anyway, just get that. So to avoid the confusion here, we put the entire radical in brackets. Yeah, so that this other number, the valency, comes here. So if I analyze this topic with examples, so let's take a look at some examples. So write the formula for each of the following compounds: potassium carbonate, ammonium carbonate, aluminium phosphate, and calcium hydrogen carbonate. So how do we tackle these ones? So we start with potassium carbonate. What is important is to identify the elements making up a given compound. And unfortunately, all the examples here, they have to do with one element and one radical. We don't have N which has just elements like sodium and chlorine. So potassium carbonate, we have potassium and carbonate. So potassium, it has got a valency, it has a symbol of K, and carbonate has got a symbol of CO3. The valence of potassium is 1 and the valence of carbonate is 2. So when we do swap, this one comes here and this 2 comes here, we're going to have K2CO3. We could have put CO3 in brackets and 1 here, but 1 doesn't affect anything. So if it's 1, you can just forget it. So we have K2CO3, and this is the symbol for potassium carbonate. Ammonium carbonate. So ammonium, if you go back to the tables, ammonium has a symbol NH4, carbonate CO3. So the valence for the radical ammonium is 1 and the valence for carbonate is 2. If you cross multiply, you are going to have this. So the 1 here has come here. So at the end of the day, 1 is supposed to be here, but because 1 we neglect it, so it cannot be shown here. The 2 has come here, but because there is 4, it's better we cover our ammonia in brackets and we have this. Aluminium and phosphate, for aluminium phosphate. So aluminium has got a valence of 3, phosphate has a valence of 3. So the 3, this 3 here from aluminium will come here, and this 3 will come here. So we're going to have this. Once you have this, because 3 and 3 are the same numbers, we can leave it like this. They can cancel, just like we did in the example where we had 1s. So we're going to have aluminium and phosphate 4. Finally, calcium and hydrogen carbonate. So we have calcium and hydrogen carbonate, which is the radical. This one, you have to master this one. Calcium is in group 2. So since it is in group 2 and it is a metal, so it has a valence of 2. Hydrogen carbonate, the inside that I had given, it has hydrogen, so it has a valence of 1. So with this, the 2 from calcium will come here, and because there's 3 here, so definitely we expect brackets here, and the 1 will come here on calcium. So when that happens, we're going to have calcium hydrogen carbonate written like this. So this marks the end of this topic. Hope you have learned what is supposed to be learned here, and I know there is a lot to take in, especially when it comes to radicals and elements, but this is chemistry, and with time you are going to get used on determining the valences and everything. What is important is you to learn how to come up with a chemical formula. Happy solving. Isn't ready? Wakimilani ikakurekodi lero nimuuza lero bize lero mtu wangu yesu alianza miko bize pamoja.